Hi guys, and welcome to your first, I suppose, official Year 13 lesson. Okay, now we are going to start our Year 13 topics. Obviously, your lessons will still be split between me and Mr. Austin, but we will only be covering pure content. Things are hopefully, we say hopefully, going to change with regards to you coming into school in a couple of weeks. To begin with, I will do chapter 2, which is functions and graphs. And Mr. Austin will start chapter 1, which looks at algebraic fractions and partial fractions. And then hopefully when you come back into school, the algebraic fractions and partial fraction stuff will be picked up by the lesson inside of school, and the functions and graphs will continue to be taught remotely. Okay. Now I know most of you will not have the Year 13 textbook yet. There is a link on Show My Homework to the Amazon copy of it. It's up to you if you want to get that ordered now or wait until the school offers it, which I'm presuming we will do at the start of next year again. Personally, I would be buying it as soon as possible, since we're going to be using it for the whole of term 6, and hopefully it would arrive a lot quicker with Amazon as well. Okay, so let's get started on functions and graphs. We've done loads of function and graph work through A level already. Okay, not masses of new stuff to look at. More than anything, it's just a little bit of new terminology and a little bit of a new way of working through certain parts. So let's have a look and get started. So we are going to start with the modulus function. Now we've seen the modulus quite a lot already, especially in mechanics. Okay, we had the modulus, so we should be relatively comfortable with that symbol. Okay, the two straight brackets effectively. Now, when we're thinking of pure maths and numerics, okay, the modulus of a number is always its non-negative numeric value. Okay, for example, the modulus of positive 6 is just 6 because it's already positive, whereas the modulus of minus 7.1 is then going to be positive 7.1. Okay, various uses for it. Obviously, we know then we're going to get a positive answer. We use it a lot when we're looking at the differences between things. Okay, so let's have a quick look at what we're going to do. So, introducing it with functions, obviously. Now you'll see we've got our function f of x is the modulus of 2x minus 3 plus 1. Okay, now I always want you to think about the modulus effectively as a set of brackets. You're always going to have to work out what goes in there first. Okay, so if we just have a look at these, so for the first one, we've got the modulus of 2 lots of 5 minus 3 plus 1. So we work out what goes inside the modulus sign first, which is going to be 7 plus 1. Now, the modulus of positive 7, it's already positive, so it doesn't actually change. So this just becomes 7 plus 1 to give us 8. Okay, look at the next one. So we will have the modulus of 2 lots of minus 2 minus 3 plus 1. Inside the brackets, we've got minus 7. So we'll have the modulus of minus 7 plus 1. Now, because I've got a negative, when I take the modulus of it, it becomes positive. So I'm left with 7 plus 1 to give me 8. Now, I would presume you're seeing how complicated these could look if our notation isn't great, because this looks like a lot. It could easily be mistaken for ones. Okay, so you've got to be really, really clear when you're using the modulus. What's your modulus signs, what's ones, and being able to decipher between them quite easily. Okay, my advice is to make sure your modulus signs are bigger so that you don't misinterpret them as ones. But guys, some of you are really going to have to work on your notation skills now to make sure we don't get confused. Okay, even more clear in this next one. So we'll go 2 lots of 1 minus 3, the modulus of that, plus 1. So this will end up being the modulus of minus 1 plus 1. Modulus of minus 1 will give us positive 1. So we'll have 1 plus 1 to give us 2. Now I just want to make this clear, just because we've got a function with a modulus in it does not mean we won't get a negative output. Okay, for example, if this number on the end was minus 5 instead, okay, if I change that to minus 5, then this answer here would end up being minus 4. Okay, so the modulus only affects what's inside it. not necessarily the whole answer. Okay, right, let's just have a look at the next part. I'm going to spend a lot of time looking at the graphs of modulus functions, okay? So we've got y equals modulus x. We'll start the same way I always want you to do. If you're ever struggling on how to draw a graph, make a table of values up and sketch it, okay? That will always give you a good base idea. You want to know what happens when it's really big. You want to know what happens when it's really small, okay? Be really careful with it. So, first part's nice and easy. They're positive, so we'll have 2, 1 and 0. Okay, and then minus 1 will become 1 and minus 2 will become 2. And you see what the graph looks like. Okay, now what's important to remember, okay, is that it's going to be reflected. Okay, so the note at the bottom, to sketch y equals the modulus of ax plus b, sketch y equals ax plus b first, then reflect upwards. Okay, because if we think y equals x would come all the way down there. So all we're doing is reflecting that part above the x-axis. Okay, now this means we don't have to plot every single point. Okay, and we can use the knowledge we've gained this year in order to do it. Okay, so let's just have a look at another one. So, sketching y equals 2x minus 3. Okay, so what I always want you to do, obviously you're going to have your axis. Okay, so we're going to start off by sketching 2x minus 3. Now, I know that that should cut at minus 3, okay, and it goes across in 2s. So let's just have a think. We're going to cross here at 3/2. Okay, so all we're going to have, and I'm going to start by doing it as a dashed line, always makes it easier, and we're going to work our way through that. Now we know with a modulus, we cannot have anything below our x-axis. Nothing can exist below that. Okay, so whenever it comes below, it gets reflected above. So this first part is absolutely fine. That's above the x-axis. This part that was below is now going to reflect above instead. So it's going to have that sort of look to it. Now, because it's reflected, this point here should be the modulus of this point here. So we'll have a crossing point at 3 instead. So you sketch your original graph, okay, sketch it with a dashed line instead. Then anything that's below the axis you reflect up. You have to remember to label all intersection points. The same as you always do with any graph, make sure your intersection points are labelled, please. Okay, right. Let's have a look at the next one. So, let's just erase the income slide. So, next one. We're now told solve 2x minus 3 equals 5. Now this is where I talk about it being really similar to what we've already done. So we know if we're given something like that, what we're looking for, okay, is to imagine our line coming across. Okay, that's what we're looking at. Now, this could be really difficult because your first thing you're going to want to do, okay, is you're going to go through and you're going to go, right, okay, so I want 2x minus 3 equals 5. So 2x will equal 8. So x will equal 4. Perfect. And that is going to be that solution there. But how am I going to get this solution? Well, what I need to do, okay, is actually work out what the equation is of this line here. That's what I need to think about. Okay. Now, we need to be careful and we need to think about this. Now, these are not perpendicular because that's what I've been told before, is automatically people have gone, it must be perpendicular. Okay, but it's not. What we've got to think about instead is what the gradient of that line is going to be. Now, because this was just reflected directly, the gradient of this part of the line, okay, is going to be the negated version of our other gradient. So that part of the line there is going to have the equation of y equals minus 2x rather than 2x, and obviously it cuts at plus 3 instead. So when I need to set this equal to 5, so I'm going to go minus 2x plus 3 equals 5. So I'll end up with minus 2x equals minus 2. Sorry, minus 2x equals positive 2 even. Can't subtract properly. So x will equal minus 1, which makes sense for the answer here. Okay, that's why it's important to sketch it, guys, because you can again have a bit more of a visual check on what you're doing. Okay, but it's all about, it's basically negating what your other equation was. So my original line had the equation of 2x minus 3. So my reflected part of the line has got the equation of y equals minus 2x instead, plus 3. Okay, and that's how it's going to work. Okay, and that just explains it a little bit more. Okay, so we're just negating that part of the graph. Right, last little bit. Solve. The modulus of 3x minus 5 equals 2 minus a half x. Okay, so sketch them both. Okay, exactly the same idea. Actually, let's go through this a little bit slower. So, first thing, we need to get used to sketching. That has not changed from year 12. I still want you to sketch. So, if I'm doing y equals 3x minus 5, I know it's supposed to cut somewhere down here at minus 5. Okay, and the intersection point there is going to be 5 over 3. So, something along the lines of that. Obviously, you'd actually want the line to be straight. Okay, so we've got that bit. Let's just go for a different colour. Right. Oh, actually, we'll finish that off first. So, once we've got to this point, again, I want to make sure it's now the modulus of 3x plus 5. So, above the axis is good. Anything below the axis gets reflected up. And again, I can work out what this point here must be, and that must be 5, because we flipped over. Okay. Then, now we'll go for a different colour. I need to do 2 minus a half x. So, I know we're going to cut at 2 here. And 2 minus a half x, so x is going to need to equal 4 when we cut across here. So, and because I'm not after the modulus, I can just draw a straight line in. Okay, I do apologise for my awful sketches, but you are more than used to them by now. Right, that means what I am now looking for, okay, is my 2 intersection points. Now this first one is going to be nice and simple. My first one is going to come from simply setting my 2 equations, my 2 functions equal to each other and solving. Okay, so I will end up with 7 over 2x equaling 7. So x is going to equal 2, which makes sense. Okay, quite happy with that. That makes sense looking at the diagram logically. I'm quite happy with that. The second intersection point is going to be a bit harder. Okay, so in order to do that, I need to know what the equation of my modulus side of the line is, where I've had to reflect up. So I negate that equation. So I'm negating all of the function 3x minus 5. So that's going to end up being y equals minus 3x plus 5. So you can negate the 3 to get a minus 3. You negate the negative 5 to get plus 5. And then again, I can set them equal to each other. So I'll have minus 3x plus 5 equals 2 minus a half x. So I'm going to end up with 5 over 2 x is going to equal 3. Minus 6 is going to equal 3. So x is going to equal 6 over 5. Okay. Which again is going to make pretty logical sense if it's in there. Okay. So there are your 2 solutions. Now guys, please, please, please don't be lazy and think you can do this without sketching it. Okay. I promise you, when these get more difficult, you will make mistakes if you have not sketched the graph. Now, in some questions, it will tell you to sketch them first, which is brilliant. That helps a lot. But it won't always be the case. Okay, sometimes you're gonna have to take that extra time, take the extra step to sketch them first, so you can visually check, so you can make sure you are happy with what you are doing. Okay, right. Oh, last little bit. Just get rid of that. So, last little bit of an inequality one. So solve where the modulus of 3x minus 5 is greater than 2 minus a half x. Again, if you've made your sketch, it makes life so much easier, because I know that my modulus function is bigger when I am greater than the biggest intersection point and smaller than the lowest intersection point. So that means that that bit is nice and simple. Okay, it's got to be less than 6/5 and greater than 2. And that makes it really nice and simple. You have got to sketch the graph, guys. Okay, right. What I want you to do is have a pause. Okay, I've been really nice and given you the graphs. Okay, given you the sketches. When you do the work from the textbook, you are going to have to sketch them yourself. Okay, have a pause, answer the questions for me. Make sure that you are finding all the solutions. Okay, so the sketches are helpful. They show you how many solutions there should be. Okay, have a pause and we will go through them afterwards. Okay guys, right, let's have a look. So, solve the modulus of x plus 1 equals 2x plus 5. Shouldn't be anything too difficult. Okay, so obviously the V-shaped one is going to be your modulus one, and you've got the 2x plus 5. Now, I haven't got a solution equal to the original part of my graph. Okay, there is no try, but it isn't going to give me a valid value, is it? Because let's just have a look. So if I set x plus 1 equal to 2x plus 5, I'm going to get x is equal to minus 4. Now, x equals minus 4 does not exist for that graph. Okay, that doesn't exist, so that can't be a valid solution. The sketch tells me that can't be a valid solution. Okay, there is no way for me to make x equal minus 4. So therefore, I'm only interested in this side of the graph. Again, to find the equation of it, negate both parts. So that will become minus x minus 1. Okay, and then I can set equal to again. So I'll have minus x minus 1 is equal to 2x plus 5. So I will end up with minus 6 is equal to 3x. So I'll have x equals minus 2, which, looking at the graph, I'm pretty happy with. That makes sense. Okay, right, second one. Modulus of 4x minus 1 is less than 2x. Again, I gave you the sketch. Okay, you've got the modulus part, you've got your y equals 2x drawn as again. Again, be careful. This time you've been given an inequality to solve. But first thing you've got to do, same as what we did earlier on in year 12, you've got to find your intersection points first. So I've got one with the original function, one with an altered function. So the original one, we'll have 4x minus 1 equals 2x. So we'll be left with 2x equaling 1. So I'll have x equaling a half, which, looking at the graph, I'm quite happy with. Need to find the equation of the second part of this modulus line. So we're going to negate both parts. Y is minus 4x plus 1. Okay, so we'll have minus 4x plus 1 equals 2x. So I'll end up with 6x equaling 1. So x is going to equal a sixth, which again makes total sense with where that intersection point is. Now, because it's an inequality, we come back to this. So I want where the modulus function is less than y equals 2x. So what I'm looking at this time is I'm looking at in between my two intersection points. Okay, so that means x will need to be less than a half and greater than a sixth. Okay, remember guys, you might be asked for it. Make sure we remember how to use our set notation. Okay, so we'll have, let's just make that a little bit neater. we can have x such that a sixth is less than x, which is less than a half. Okay, again, just a little bit of extra stuff that you might need to remember. Remember how to solve from them. Okay, so it's making sure you remember how to find the second part of the modulus sign. Okay, right. Can we please have a look on Show My Homework and see which questions I want you to do from exercise 2A?